Something unusual has entered our solar system, an object moving with the quiet certainty of something that does not belong here. Astronomers first noticed it as a dim blot in the sky, a line of motion where there should have been stillness. At the time, no one understood what they were looking at. They only saw a faint traveler drifting across the background stars, following a path no comet from our system could ever take. Its name is 3I Atlas, the third confirmed interstellar visitor in human history. Yet from the moment it appeared, 3I Atlas refused to behave like any ordinary object. It arrived with the speed of something flung out of another star's gravity well, and the precision of something guided. Over the last several weeks, telescopes around the world have captured details so strange, so difficult to reconcile with what a natural comet should be, that researchers across multiple agencies quietly admit the same thing. Nothing about this object is normal. As 3I Atlas approaches the inner solar system, a cascade of mysteries has emerged: patterns of light, jets of material, questionable accelerations, and a trajectory so exact that some believe coincidence alone cannot account for it. This is the story of an interstellar visitor whose behavior challenges every assumption we have about what drifts between the stars. Fresh images taken between November 22nd and 24th changed the conversation entirely. Powerful ground-based telescopes in Spain and Chile captured 3I Atlas with unprecedented clarity. One image, taken by astrophotographer Mitsunori Tamura using a half-meter telescope, stunned even the most skeptical astronomers. The object possessed a vast, glowing coma, but that was only the beginning. Emerging from the nucleus were two distinct structures. One was expected, a tail stretching nearly 5 million kilometers away from the Sun, a shimmering stream of dust and gas. The other was not. A second tail, an anti-tail, extended more than 1 million kilometers toward the Sun. It pushed directly against the solar wind, a stream of charged particles blasting outward at 400 kilometers per second. To move into that stream, to carve through it, the mass of the material being ejected from 3I Atlas must be enormous. Calculations show the density of this sunward jet to be at least 1 million times greater than the surrounding solar wind. No comet in the record has ever displayed such a forceful counterflow at such extreme distances. If 3I Atlas is natural, it is undergoing a level of violent mass loss that borders on catastrophic. The numbers suggest it may have shed more than 10% of its total mass in only 2 months. But if the anti-tail is not just a natural release, if it is focused, directional, and sustained, then the forces acting on this object may be far more complicated than simple sunlight striking ice. But the brightest mystery comes from its movement. New trajectory measurements reveal that 3I Atlas is experiencing non-gravitational acceleration, a change in its path not accounted for by the Sun, the planets, or any known gravitational influence. But the brightest mystery comes from its movement. New trajectory measurements reveal that 3I Atlas is experiencing non-gravitational acceleration, a change in its path not accounted for by the Sun, the planets, or any known gravitational influence. The effect is now measured with a statistical confidence of 10 standard deviations, far beyond any margin of error. Natural comets exhibit similar behavior, but only when massive, uneven jets of sublimating ice act like miniature thrusters. For a comet from our solar system, this is well understood. But for 3I Atlas, the math doesn't quite add up. The acceleration is too clean, too smooth, too consistent. To produce this motion, the object would need to expel unbelievable amounts of gas and dust. And while 3I Atlas is certainly shedding material, the amount does not match the level of propulsion implied by its altered trajectory. Some researchers quietly note that a controlled thrust, chemical or ion-driven, would require far less mass loss to achieve the same effect. The data does not prove this, nor does it definitively suggest artificial origin, but it leaves the door open. and for many, that alone is unsettling. Yet the strangest part of the story lies ahead. On March 16, 2026, 3I Atlas will enter Jupiter's Hill sphere, the region where the giant planet's gravity outweighs the Sun's pull. It will not collide with Jupiter, but the gravitational encounter will be dramatic. This is the first time in history that an interstellar object will drift so close to one of our planets. What astonishes scientists is not the encounter itself, but the accuracy of its predicted approach. Current calculations place its entry into Jupiter's influence with precision beyond 4 significant digits, something exceedingly rare for an object supposedly tumbling freely through space for millions of years. How did an interstellar body, drifting across the galaxy, arrive with a trajectory so exquisitely aligned that it threads itself through the outskirts of Jupiter's gravitational boundary? Coincidence is possible, but coincidence on this scale invites questions. NASA's Juno spacecraft may be perfectly positioned to observe this cosmic dance. If so, humanity could witness an unprecedented event: a probe orbiting Jupiter capturing real-time changes in the motion of a visitor from another star. Any deviations in direction, any shifts in acceleration, any unnatural symmetry in its response could reveal secrets about its structure, composition, and perhaps its origin. Before Jupiter sees it, Earth will. On December 19, 2025, 3I Atlas will pass within 269 million kilometers of our planet, close enough for the Hubble Space Telescope, the James Webb Space Telescope, and multiple ground-based observatories to study it in detail. This is our best and possibly only opportunity to see its nucleus clearly. For now, the coma is too bright. The nucleus remains hidden beneath layers of gas and dust. But during December's approach, a direct view may become possible. Scientists hope to catch a glimpse, any glimpse, of the solid object at its heart. Will it resemble a typical cometary core, or will it show geometric edges, unusual symmetry, or reflectivity patterns that challenge expectations? No one can say. But whatever we see, it will have implications far beyond this one encounter. Another anomaly lies in its luminosity. 3I Atlas is brighter than it should be, much brighter. Brightness in comets typically follows a predictable curve based on their distance from the Sun. The relationship is reliable enough that astronomers use it to estimate a comet's size and composition. But 3I Atlas is defying those models with startling consistency. Research from the Lowell Observatory and the U.S. Naval Research Laboratory reveals that its brightness increases with a power of nearly 7.5 relative to its distance from the Sun. By contrast, comets from our own Oort cloud usually show an exponent between 2 and 4. This means 3I Atlas is brightening nearly twice as fast as the most volatile comets known. Two explanations dominate the discussion. Possibility 1. Exotic composition. The object could contain supervolatile ices, common in the cold regions between stars, materials that vaporize rapidly even under weak sunlight. Nitrogen ice, carbon monoxide, carbon dioxide, rare compounds that might behave violently when exposed to warmer temperatures. If true, 3I Atlas is a pristine sample of chemistry from a distant stellar neighborhood. Another theory suggests that 3I Atlas is breaking apart, exposing fresh material and reflecting more sunlight. But typical fragmentation produces uneven light curves, flickering and pulsing with time. 3I Atlas does not flicker. Its brightness follows a smooth, continuous rise. This smoothness and the focused nature of its jets raises uncomfortable questions. Comets rotate irregularly. Their jets flicker as different surfaces heat and cool. Their brightness varies unpredictably. But 3I Atlas is different. The jets emerging from its nucleus appear tightly collimated, focused into narrow streams rather than dispersed plumes. And they remain stable over time, suggesting a level of uniformity or control not seen in most natural comets. There is no proof these jets are artificial, but their behavior is unusually structured. Some researchers point out that the non-gravitational acceleration, the brightness consistency, and the directional jets all share one feature. They are too orderly. Natural objects tend toward chaos. 3I Atlas leans toward symmetry. To grasp the importance of this moment, it helps to remember how little we know about interstellar material. Everything in our solar system formed from the same ancient cloud, sharing the same chemistry and origin. But 3I Atlas is different. Its atoms were born around another star. Its ices condensed in a distant cosmic winter. Its structure was shaped by conditions that have nothing in common with our sun. Every measurement tells a story from somewhere else: a far-off stellar nursery, a shattered planetary system, a collision that sent it drifting toward our neighborhood. And now, after countless years in the dark between stars, it is here, shedding its secrets as it races past our world. After its encounter with Jupiter in March, 3I Atlas will be thrown outward, accelerating as it climbs away from the sun. Within a few years, it will fade into the black, too distant for telescopes to follow. It will return to the silence of interstellar space, carrying whatever secrets remain undiscovered. This may be our only chance to study it. There is no guarantee another interstellar visitor will come soon. The gaps between detections are unpredictable: months, years, decades. No one knows how many wanderers pass through unseen. Some are bright and dramatic. Others move like shadows, invisible in the noise. 3I Atlas is the rare one that revealed itself. Right now, observatories around the world are preparing for December's approach. Instruments are being tuned, schedules rewritten, and observation windows coordinated across continents. From small amateur telescopes to billion-dollar space observatories, all eyes are turning toward a single point of light drifting through the void. Its behavior is strange, its path is precise, its origin is unknown. And in the coming weeks, the data we gather may reshape our understanding of what moves between the stars. 3I Atlas may be a natural comet with extraordinary properties. It may be a fragment of a distant world unlike anything in our catalog. Or it may be something we have not yet imagined. Whatever the truth is, one fact remains certain, and soon we will finally learn what it is.